Hello and welcome to our webinar, The Data Lakehouse Made Simple with BARC and 𝗬𝗫𝗀. My name is 𝗚𝗂𝗶𝗃𝗍𝗄. I'll be your moderator for this webinar. I have the honor to introduce our two great speakers of the day. On the one hand, we have Thomas Zeutschler. He's a senior analyst with BARC and a veteran in data analytics. He used to run the data analytics department at Henkel, just to name one example of his wealth of experiences in the field. And on the other hand, we have Will Martin. Will is an evangelist for 𝗬𝗫𝗀𝗻. He has a PhD in physics, an impressive CV that includes working at CERN in Switzerland, for Deloitte, and also as a data ops engineer. Before I hand over to the speakers, just a little bit of housekeeping. We invite you to ask questions to the speakers. We have a Q&A session after the presentations where we'll try to answer as many of your questions as we can. In case we do not have time for all your questions, we will answer them after the webinar via email. So please feel free to ask as many questions as you like. The speakers are happy to connect with you on LinkedIn. You can find them on LinkedIn if you want to. So reach out to them via LinkedIn as well. And now I have the honor to hand over to Thomas for our first session.
Okay, so that's me. I hope you see me. And I will directly jump into the topic. Data Lakehouse Made Simple. Oh, promise or overpromise? Let's see. So first, some words to me. My name is Thomas Zeutschler. I'm a fellow and senior analyst by BARC, and I spent my entire life, hopefully it's going on data and analytics and doing projects and building solutions in that area. Yeah? And now I'm 4 years with BARC, and I'm consulting mainly larger companies in regards of data architecture, data strategy, how to build analytical skills and stuff like that. Important aspect. Along this nice presentation, there is a new paper from BARC. It's called the Lakehouse Cookbook. Yeah, you as the participants will anyhow receive a copy of that, and all I'm telling, yeah, and much more in detail is contained in this book. You can also download it as you like, yeah, but you will also receive afterwards a copy anyhow. Yeah. Okay, so let's jump into the topic itself. A very short history on data lakehouse. When we talk about all these data things, then we should remember that it's mainly 70, 80 years old, yeah, or 70 years old, as you see, when larger computers came out. And at that time, computing was very much an exclusive thing. It was super expensive. When we directly go forward to today, you will find out that we will have capabilities that far extend what was possible at that time in the past. But saying that, the analytical capabilities in regards of mathematics and so on and so forth were not much different 70 years before than yet. The only difference is new computers, new capabilities, and anything is faster. And that changed many things over time. And when we look back at that time, in the very early days, we had these very early databases, hierarchical databases. There was a strong differentiation between that is a computer, that is the data, that was just files, and the disk you have seen on the picture before. Then we had this area of relational databases where we said, oh, stop. If you put data and storage together, have a good look on the data, then we can get much better in processing this data. Then we move on. Then we have this big area of data warehouses, big appliances, super expensive, super fast, where you can say, okay, it has to be all one. Compute, data, storage, all is integrated, and that's how it's working. But also, this concept does or did not really deliver as expected. And that was the time when classical cloud data warehousing starts. Yeah? And the idea was to put away the storage layer and say, hey, we use just what is available in cloud environments. It's cheap, it's fast, it's endless available. That's a good idea. And the final step, and that is where we are currently in, is this Lakehouse movement, where again the idea is to say, hey, let's put these things aside. We have compute, that's one thing. Data is one thing, and storage is one thing. The main difference here to what we had before, and it looks very much like in the 60s, is that we now do not speak any longer about technologies so much, but about concepts. And that is the main difference between data lakehouse and data warehouse. Data warehouse is always tied to certain technologies, and lakehouse is really more a concept, and as we will see, an open concept. If we look into the future, speaking of today, we all see, okay, this AI thing is taking its pace and it's going on. My personal prediction is that we will see that this development is going on. We will get more and more AI, not only on the compute layer, but also maybe in finding out what are data structures, and maybe also on the storage layer. And at the long term, but we are not yet there, we will see if this compute thing and this data thing still requires our input in regards of what are relations, what are sources. I strongly believe that this will change, and we will move on from asking questions just to evaluating insights that are proposed to us. Yeah? That will be likely the future we are going to. Coming back to the Lakehouse itself, I talked about files, and the cool thing about Lakehouse that it's mainly based on this idea of we define how data looks like, and that is just files if you really look to it. Yeah. And when you look, for instance, about the minimum size of a data set, yeah, this is a comparison of a medium-sized data set, 1.5, close to 1.5 million rows, yeah, and the size, the sheer size of the data. When you look for it at CSV, what is already a quite compact format, and then you can zip it, it's even smaller, and that is in our mind already the smallest thing you can find. Then you find out that these new formats are even more compact. And as size matters and performance matters, it's very important to have these files very small. And that leads finally to an, if you say, hey, we are just working on files on a disk, to an unbelievable performance ratio. When you really have a comparison between a classical data warehouse or a classical database and a modern lakehouse, then you will find out, it's not slower, it's even faster. And if you scale up, it's so much faster, or can be so much faster than classical technologies. And that is what this movement is all about. Yeah, it's really fast. This measure, what you see in here, fast as a database, 35 million records per second, that's measured on a lousy M1 Air laptop. So it's not a supercomputer or anything. That means that we get more and more capabilities with the current technologies in our hand to analyze data, and that at more or less any kind of scale. And that leads to the fact that you become, or can become, yeah, a data magnician somehow. And this magnician, for sure you need a laptop, stuff like that, or a big computer, or network, or cluster, or anything. What you need is building blocks, and all these building blocks, and there are a lot around. These are just a few names, just to name it. Yeah? And these technologies, and that is a very different quality of working with professional tools, is that all these things are free, or most of them are free, and all of them are really open. And openness is an important aspect of the story. And this openness leads to a very high quality of these services, a super broad adoption. And what we now see is that all these different technologies are out there and proprietary things are converging together against these modern and open standards. Yeah. And this open source idea, that's an important thing. A lot of people get a bad feeling when, oh, open source, let's go away. We need professional services. But the basic idea of shared efforts, or people working together on something used for the individual access, that I think is, especially in the data and analytics and in AI environment, is the model of the decade, yeah, and hopefully also of the future, because all the very fast pacing advances in technologies and algorithms is based on this openness and sharing, and that many people work on this. And when you look at all these symbols I showed on the page before, when you look who's developing this actually, yeah, a lot of people have in mind, oh, these are these nerds sitting there, pizza eating, open source, whatever. No, it's not the case. When you look at all this, I would say 90% is really driven by professionals and all the big tech guys. And why do they do this? Because they have a personal interest to do it efficiently. For instance, AWS or Microsoft, they all use these technologies to make their services cheaper, more robust, more reliable, easier to approach also for customers. Finally, just for one reason, as we all do, making more money. And that's the reason why this is a huge success and everyone is following on these new open standards. And this is good for us as a user of certain things. This openness is creating an enormous pressure on the vendors. Yeah. So 10, 20 years before, anything was closed shop. You cannot really compare things to each other. Now it's very open, and you can decide tomorrow, oh, I do not like AWS anymore. I want to go to Azure. Oh, Azure is also not fun. I want to go on to Google. Yeah. All this is possible today. Yeah, and this puts pressure on these guys, and therefore they have to innovate, and that is a good thing. Yeah, it's also for sure creating cost pressure, yeah, or pricing pressure, because it's very transparent what you get. Yeah, and that's a good thing for us. And the next thing, or the final thing, is this minimizes also the vendor lock-in. That means when you go for these open standards, which Data Lakehouse is, yeah, you are not locked into a certain vendor. When you say, oh, my query engine A, I do not like it. It looks green. I want a blue one. You can easily change. Yeah, and you can easily also adapt new innovations, because all these things easily support this new and open standard, and that's a good thing. Yeah, I think we have great years ahead of us in regards of data management, data analytics, and also democratizing all these capabilities to business users. But how to get started on the Lakehouse? So for me, Lakehouse is a continuum. It starts with very simple things. I have to add up two numbers, or super complex things. I do not want to write here, fly me to Mars, because you know why. That's the reason why I said moon. Yeah, but anyhow. And a lot of people, and still this, yeah, so do not blame Excel. It's the most used tool on this planet for doing data stuff. Yeah? You can do a lot of things, but it has a natural end. It has a span in which you can work with it, and it's very limited. Those who already work with Excel extensively know that. And you can develop custom solutions, yeah, to do very, very special things, and you also need to do this. Data and analytics has a super broad span over this continuum. For sure, if you need to add up 1 and 1, you do not need much intelligence or much computational power, but it easily starts to extend. The data warehouse, as we know it, and it might be an even big one, yeah, has a quite limited space, because for very small things, it is often not worth to spin all the things up. Yeah, and as we already know, once you exceed certain sizes of data, and we talk about petabytes, and there are already companies out who are working in the exabyte area, yeah, based on data lakehouse technology, yeah, there is that's out of the comfort zone for a normal data warehouse anymore. And now comes the most important thing. With just file-based data processing, I'm not speaking about Lakehouse here, but working file-based, you can easily start. It's as easy as Excel, and it moves on to really large use cases. And this hands perfectly over, and you can start with your journey, however what you want to do. And the data lakehouse is the perfect compendium because it blends easily from this file-based approach to this data lakehouse approach. And that is a great opportunity also for business users to make them or enable them to use modern data technologies. I think Lakehouse is really a technology that is very much capable to be used by business users. And I first said assumptions, but I let this word in and I changed it to observations. If we look at today's business, what we easily can find out, really everyone needs to work with data somehow. There is not a single person, a blue-collar worker, whatever that is, who not has to deal with data, even on a quite complex level. So everyone needs to do it. And I also would assume, because that's also in our DNA and our history, we are able to analyze data. We can look at data because we can also observe the environment. Yeah. And why are we good at that to a certain degree is because we need for our daily lives, we have to have actionable insights. Yeah. Should I now take this 5 meters to the refrigerator, open it and get me whatever yogurt, yeah, or not? And the same is true in business context. That means there's nothing is purposeless and people do this, they can do this. Yeah. And I believe also that everyone, because we all have phones, laptops, we are super educated, everyone. Yeah, they can learn to use these modern data tools. Yeah, like for instance, just names could be different tools. Yeah, a visual data analyst with Tableau, or even data analysts with Python. Yeah, a lot of people say, "Ooh, programming language, go away." But once they get used how simple this could be, they find out, oh, that's even more simple than Excel. Yeah, and people should get used to these capabilities just to work on more actionable insights. And my belief is that these self-service data processing and analysis, yeah, that is a key skill that we should first enable and foster. We should bring the tools and capability to users that they can work on this stuff. Yeah, and as everyone wants to do analytics and AI use cases in the enterprise space, but a lot of outcomes are still low or minimal or not as expected. The question is, why is this? Because normally we would assume that people are able to do so because I said just they can analyze data. But when you really look into the depths of and the steps of how a use case is made of, yeah, then you will find easily out that these steps, yeah, they also are described in much more depth in this paper, yeah, that people struggle with a lot of things. And they struggle, for instance, with just asking a quantifiable business question or business target. Yeah, that is not an easy thing to find out. We want to do this by 5% or whatever. Yeah, and then it goes on because at a certain point in time, you need to start to collect data, work on these input variables, identify relevant data, and you need a certain tool set. And Excel is often not enough. But jumping into this file-based stuff, and I believe it's approachable really for everyone. I do a lot of trainings in this area, and it always works out. You can really jump into this topic and you can see how people's eyes are enlightening and say, oh, that is possible. It is so easy. And the good thing is, yeah, that these steps, I now start with again, these 5 steps, they're also in the paper, yeah, so that you can really start with a small footprint, yeah, just work on the data, yeah. Then also the next step that you say, hey, your data is not anymore on your laptop, it's now in the cloud, but you can still work from your laptop on all these things. Yeah. And when your use case is going to that area, you can say, okay, now we have to have a little bit more structure in our setup, and we apply this Lakehouse approach, which is much more professional. Yeah, and then you can move on and say, okay, now we bring more order and structure, we establish governance and all these things. And finally, that you end up with certain things like semantics, collaboration, and data products. with modern platforms, you can even start really with the last step, because modern tools bring such capabilities quite easily to the desk. Yeah, and that is then the basis of modern data management, how interested people, interested organizations, and especially business users can approach this. You can really start super small. Again, look into the paper. You can easily master these super performant and easy to manage Parquet files. And you can also try this modern data visualization, where you do not have anymore this big cycle of putting data here and there and there and there, and it's always persisted. And you can easily move on to this Lakehouse experience, starting with just files and going on to this Lakehouse approach. And the cool thing, again, it's all based on standards. It's all open technology. It's approachable. You are never in a dead end with these technologies. And all the modern tools are going into that direction. Yeah. Okay. Now, modern data management using Lakehouse. You know this classic data warehouse architecture, I assume, where you have ingestion, bronze, silver, and all these things. And at the bottom end, you have your enterprise use cases. This has already dramatically changed, because the challenge that we have more and more and increasingly more data sources. And I can already predict in 4 years from now, you likely have 4 times the data you have now. Are you prepared to work with this? Do you have the structures in place to manage this, to cope with all this demand? Yeah. And I think we need a more lightweight approach to all of this. I do not say that the old concept is wrong or whatever. I say it's just too heavy. When you persist data from raw to silver to gold into a data mart, that's a huge amount of work. Do I really need to do this? Why do we do this? We do it only because we have no tools directly to work on this raw layer. That's more or less the only reason. For sure, you need some governance and all these things, but the main reason is it didn't work out. Lakehouse technology, on the other side, is really amazing in these areas, and we see more and more use cases, and really large use cases, where the silver gold layer and even this platinum layer is barely persisted to disk at all. Yeah, so it's just query on query on query on the raw data. And my first belief when I saw these technologies, I said, that's too slow. Yeah, but I have to be honest, I've seen really solutions where I said, ooh, that is fast. And I can just engage you to also try this. And another challenge is that we have to tackle with is the fact that in former times, the people were just working against these data marts and analyzing their data there. But as data and analytics gets more and more operational, yeah, and it's not about just looking and controlling, but part of the core business, these use cases have to really dig down into all of these layers, really down to the raw layer and even to the raw data itself from the systems. Yeah? And you need a platform that is able to do this, to bring all these things together. And that is not an easy thing, I think. Yeah. And there are these modern Lakehouse platforms. There are many out. Look out what is available. They are really a perfect basis for doing this. And the cool thing is the step from, I'm working on my PC and moving on, a first step into that direction is because you can easily spin up these services and use it. It's so easy, and it then scales really to any enterprise use case you can think of. Yeah. So in my previous company, we had an architecture like this, and we had over 7,000 users on this system. And when we first started with this Lakehouse thing, we said, no, we need the warehouse. Yeah, it does not work. For the raw data, we can use it. But the more we stepped into this, we found out, hey, it really addresses all these things, and it brings a lot of additional benefits with it. Cost aside, yeah. So cost is a big topic. It's also described in the paper quite nicely, yeah. But it's really a new thing, a new way of working with data, and I love it, yeah. And let's see how this works out. I believe, and this is already because I only have 30 minutes. Normally, I can talk 4 hours, yeah, in a straight line, but stop me. Outlook, innovations. I think we will see a lot of innovations coming up. And most of them will be based on these new and open data formats and data technologies, because that is easy to adopt and it had already set the standards. Yeah, so there are vendors for classical databases out there. I do not name those. I do not say names. Yeah, but these companies totally switched away from proprietary formats and go totally to these open formats. Yeah, and why do they do this? Not because they are going harakiri, yeah, but they see that this is really working and that this is the point in time where you have to do this. So the AI impact, that is still in its early phase. So we are not yet at a peak or what anything else. It's very bare still. Yeah, I believe in the upcoming years this will be dramatical. Then also the importance of performance. I'm a performance guy. I hate slow things. Yeah, so my personal rule is always 3 seconds. Anything that takes more than 3 seconds it's a waste of time. Yeah, and too slow and too expensive. Because if you look for high performance, and I would always would like to motivate you to do this, that's always low cost, less time, and it's also good support for real-time business scenarios and use cases. And the biggest thing, and therefore I think these platforms are really the solution, is to bring a level and an ease of use to end users so that they can work with it. I also do not believe that our world will be saved with millions of data scientists. No, it's everyone out there in the business. Enable these people. They have the big business inside. They know their business. They can provide you the best information. And if you enable these, yeah, that is much more valuable than to think about super big pictures. My experience. Yeah? So and also, and that's the other thing, the ease of operations for data engineers. Yeah, if you have not this ETL processing anymore, if you can deal easily with terabyte-sized data pools, yeah, that's a good thing. Yeah, and for that reason, I also believe that this virtualization, so not persisting and not all these ETL, ELT processing anymore, but just through queries, you are going down to the data, that this is the future. By that, I'm already in time. That's important, otherwise I get hurt. Again, to this book, yeah, because I had very short time. If you go into this paper, you will find a lot of these basic ideas written down, taken down, a lot of cool use cases that you can work on. And yeah, that is. And by that, I would like to directly hand over to my colleague, and we will go, and Will is also the name, yeah, and will show you now the product, and afterwards we will start to have certain questions and discussions. Will, please.
Great. Thank you, Thomas. Hi, everybody. I'm here to complement what Thomas has been saying, and I'm going to talk a little bit about data lakehouses, so what they are, kind of features they have, what you can do with them, and then I'll also be going into a bunch of customer stories from customers we have here at Dremio and what they've been able to do by leveraging lakehouses. So, hi, just to repeat a little what you heard already, I'm Will. I'm the EMEA technical evangelist here at Dremio. I've got over a decade's experience working with data across various industries and academia, and now I'm here with Dremio to tell you about Boston Lakehouses. So who are we? We're a hybrid lakehouse platform for self-service analytics at scale. We're headquartered in California and founded in 2015. We have employees spread across 8 different countries and a large range of customers. So you'll see some logos down there at the bottom, and I'll show you some more a bit later and in a bit more detail. And out of those, we have 22 in the Fortune 100 and 5 in the Fortune 10. So what is a lakehouse? Some of you may be asking. It's a combination of a data lake and a data warehouse. And in terms of the technologies, it's a combination. So what you're trying to do is bring in the best of both. So you want the low-cost, scalable storage you get with a data lake, but you want the consistent performant transactions you'd get from a data warehouse. And how do you get a data lakehouse? Well, you're not ripping, replacing. Just like the term lakehouse and the concept there, you get a lakehouse by taking a data lake and adding to it. So on the right here is a representative example of a data lake. You're probably familiar with it. You may even use one yourself. So you have your two components, the storage and your compute. They're decoupled, so they're scalable, and that's your lake. So how do I go from this to a lake house? You just add to it. So by adding in these two other components, a table format and a data catalog, your lake has now become a lake house. And these two things are as such. So a table format is metadata that defines your data table. And then your data catalog provides whoever wants to use that table with the correct version of it. I'll go into each of those a little bit more on the next few slides. So firstly, table formats. As I said, they're metadata, and it's a specification for that information. And this information is used to explicitly define your data table. So the kind of information stored in this metadata are the schema for your data table. So these are your columns, what they're called, what the variable types are. You also contain your partitioning information. So this is the list of files that make up your table, and also the physical locations for them, where they are in your storage. And it also stores the history of your table. So whatever's been added, deleted, or edited. And with this information stored as metadata, there's some really powerful things you can do. So one of these is schema evolution. So you can change your schema, your attributes and what they are, without touching your data. So that stays in the data lake. You're not editing it, rewriting it, or moving it. You can change your columns. And with this history information in your metadata, you can roll back in case of data destruction or as a recovery method. And also there's some very powerful time travel capabilities. So your scientists can very easily look at historical data and run analyses. You also now have guaranteed ACID transactions. And again, your data is still there in the lake. You're not moving it out. And that's very powerful. You also have faster querying. It's a very performant technology. And it's an open standard, like Thomas was saying earlier in his presentation. Going with a table format, you're not locking yourself in with a vendor or transforming your data into a format that no one else is using. And then finally, down at the bottom here in blue, I have two features that are specific to Apache Iceberg, which is a specific table format. One of these is partition evolution. So this is very similar to schema evolution, but you can change how your data is partitioned without touching or rewriting your data in storage. And the second good feature of Iceberg is the broad support. So in the last year, Iceberg has come to the forefront as the leading table format. And you can see this in the news announcements of the last year. So things like AWS's announcement at their reInvent conference, and also the acquisition of Tabular by Databricks. So that's the first component that turns your lake to a lake house. The second one is a data catalog. And a data catalog does two key things. It lists all the tables in your storage, and it maintains a reference to the current metadata for each table. Broadly speaking, there's two catalogs you'd hear discussed, and I'll go into each of those. The first one is a Lakehouse catalog. You'll sometimes hear us at Dremio, if you go to our website, we sometimes call it an Iceberg catalog. And really, this is an execution level catalog. It tells your query engine or your compute what tables you have in your storage. And you can see this on the right of the slide. It kind of sits as a middleman between the storage and the compute. The second type is an enterprise data catalog. And this is a user level catalog. So your people using the platform, your business users, can actually see what tables are available and also request access and get access for them. So it's more of a platform capability. Okay, so those are your two objects. So you have your lake, you have your format, you have your catalog. Together, that gives you a lakehouse. And this is Dremio's Lakehouse platform in a diagram. You may be more familiar with this kind of diagram going left to right, but we go bottom up. So at the bottom, we have the data sources we work with. So both cloud and on-prem. I've been mainly talking about lakes and cloud storage, but we also work with on-prem databases and even other data platforms such as Snowflake and Databricks. I've mentioned Iceberg a bit. We are Iceberg native at Dremio, so we can leverage all the capabilities of it, but we're not locked into it. We also work with Delta Lake, and we also work with a variety of Lakehouse catalogs, our own, obviously, but also Polaris and ones from other vendors such as Unity Catalog. So this is all your data and the management of your data. This goes into the Dremio platform, and out the other end comes the typical things like your apps, your information to your data scientists and your dashboards. But in the middle is where the work happens. So we have three main sort of central pillars we have at Dremio and functionality. And there was such, you start with unified analytics. This is self-service analytics. And the idea here is to get your data accessible to your business users in your company. They get to leverage their expertise and get better data that they can then share within your organization. Secondly, we've got our industry-leading SQL query engine. This is in terms of price and query performance. And this is multi-cloud and hybrid. So if I could draw your attention back down to the bottom, we have this nice list of logos down here. These are all the things we work with, all the sources we interact with, but they're not exclusive. It's not either or. You can pick whichever combination you have. So the idea of a lakehouse and querying your data where it is very true on Dremio as a whole, even if it's not technically in a lake. So you keep your data where it is, where you want it to be, and with Dremio you can analyze it. And the reason you keep your data where it is can be for whatever reasons you want, whether it's cost, security, peace of mind, or even convenience. Keep your data where you want it. And then finally, we have Lakehouse management. So this is the enterprise data catalog I was talking about, and this helps you manage your data. And really the key theme for our platform is centralization. So with these three pillars, we unify your access, we unify your analysis, and we unify your management of your data. So that's the platform. That's a bunch of features. But what can you do with it? I'll give you some examples. So broadly speaking, we have 6 main use cases here at Dremio, and these are a bunch of logos for companies we work with who are doing these kinds of use cases. I'm going to go into 3 now on this presentation, but if you see any logos here you're interested in and I don't talk about them in the next few minutes, please go ahead to our website. We have pages for the use cases and pages for specific customers too, with lots of information. Okay, firstly, I'm going to talk about Maersk. You probably know them, global leader in container shipping and logistics, and we saved them millions by helping them switch to Dremio. So their pain points are the kind of things you usually hear about. They had slow dashboarding, the reporting tools were kind of laggy, and costs were going up, right? And you can see here on the right in the upper section, this is their previous architecture. There's a few components here. They've got their data lake, their Databricks, some analysis services, and then they're also pushing out extracts and re-ingesting them into a BI tool. So here's the complexity they were struggling with. And another point on this was it was difficult to get users involved. So this self-service aspect really wasn't getting any traction because the platform, the architecture was quite complicated. So what we did is we removed the middle and replaced it with Dremio. So this becomes a very nice example of what I was discussing earlier. You have your lake, your lakehouse, and then your output. And these work quite smoothly together. So Dremio is analyzing the data in the data lake. It's not being pulled out, ingested into anything else. And then the data from Dremio goes very smoothly into Power BI because we have a direct connector. There's no extracts or loading. We load the complexity here, we load their costs, and the self-service aspect really went up and was widely adopted at Maersk, and they got over 5,000 users within a year. Another example is 𝗘𝘅𝗽𝗄𝗏, warehouse equipment manufacturer in Europe. Likewise, resources costs are going up, architecture is complex, but the architecture is kind of a little bit different here. It's quite interesting. So what happened here is they didn't replace lots of services with Dremio. They picked the component that was suitable for them. So here's their final architecture with us in place. They were previously working on Azure Data Factory and they stayed there, and they leveraged Databricks for their processing and their cleaning, so their ETL. But they substituted out whatever they were using with our SQL engine because it was more performant. And this gave a boost. So the complexity went down a little bit, but the true revelation here was the BI dashboards. They got a quicker turnaround. The business became more dynamic because they were more responsive in their analysis, and they could do better data-driven decisions. So one of the things Thomas was talking about and myself was trying to focus on that actually Dremio is quite easy to get started with and move over with, and it's very flexible. You're not replacing everything. You're not decommissioning anything. As I was discussing earlier, your lake can turn into a lake house relatively easily. But sometimes you do have to decommission, and Dremio can also be there for you if that's what you need to do. So JP Chase is a customer we've worked with that had to do that. They had a legacy warehouse and it was going end of life. So this big business critical piece of infrastructure had to go, and it had to go quickly. And we came in and satisfied that. We deployed on-prem because of their data requirements. And we did the same for the other customers I've talked about. We reduced the complexity and the performance went up, and there's a significant ROI. As you can imagine, if you're mothballing a legacy piece of infrastructure like that. So those are some specific examples, but here are some stats from across our customers. So we've seen that we're the best in class in terms of total cost of ownership. Many of our customers see over a 50% reduced analytics cost, and that's within 1 year. So you're not paying a large amount upfront and paying it off and seeing the benefit over time. It's very quick in terms of the benefits. I talked about our SQL engine previously. So in terms of performance, 10x compared to some competitors, and in terms of price performance compared to Trino, it was also in the data lakehouse space with a 9x better price performance. And for one specific customer, their ETL savings were 75%. And again, that's within 1 year, just from how we simplified the engineering and the architecture with a lakehouse. And that's it for me. Thank you for listening. If you liked anything that I was discussing, here's some links to more details and more resources. If you're technically minded, on the left, there is a link for the Apache Iceberg book, which is really informative. And if you're business minded, on the right, there is a link for our State of the Data Lakehouse survey report that we just put out for 2025. This goes into AI data, and we've surveyed about 560 people across various industries globally, talked about what they're doing with lakehouses and predictions for the new year coming ahead. And finally, if Thomas and I have done our job and you're interested in using Dremio, here's a link to our Dremio University page. We've got courses on various parts of Dremio, but also their technology. So Iceberg, things like this. If you're practically minded, you can spin up Dremio and do some SQL yourself, and even earn some badges there, become verified. Okay, and that's it from me. Thank you. I'm going to hand over back to Axel.
Great. Thanks so much to the both of you. Very interesting. We did get quite a few questions for both of you, and I can already tell that we won't be able to answer all of them. So again, the hint that we will definitely answer all your questions, and those that we cannot answer now, we will answer afterwards via email. So let me get straight to it. I have a couple for Thomas here.
Yep.
So one would be, what does BARC see is the current adoption of data lakehouse versus classical warehouses?
So from our observations, we do a lot of market studies and so on. It's not an exact figure, but the assumption is that 80% of, let's say, data warehouse projects, data warehouse modernization projects are already in the space of data lakehouse. So the movement is huge. And when you are mainly on this analytical focus, so if you're not trying to run your SAP system on a data lakehouse, which is maybe a nice exercise, you are totally fine with this technology. In regards of performance, scale, security, all the aspects, the enterprise aspects, they are all covered. Again, 80% I think is the ratio of enterprises who are already adopting it, and it's permanently increasing. And what Will said, also it seems that the Apache Iceberg format, because it's a really open format driven by a lot of companies, that seems to be the upcoming market standard. Yeah. What is a good thing just to have one. Yeah.
Okay. So one more for you, maybe, Thomas. Are there scenarios where you would recommend against a data warehouse? When should you not create a data warehouse, or is it straight up the best approach we currently got?
Data warehouse is a very general concept, and for sure, if you go data lakehouse, you still follow these data warehouse concepts that we had before, because it behaves as one. I would say that it's very special use cases. And it's not that you do not need a data lakehouse, because what we see is that the first layer of data for more and more use cases is a data lake. And increasingly, because the step from a data lake to a data lakehouse is not a big one, we see that a lot of companies adopting this, because then you also have much more structure in your classical data lake environment. You have this time travel, schema evolution, and all these things. And that is what is very often also in front of other solutions. For instance, vector databases are currently very much on vogue for AI topics, but also they need to get their data somewhere. Where's the data residing? A data lake, a lakehouse, still an optimal solution. The same is true if you go for other database concepts like let's say document-based stuff, or where your network-based databases is. All there, it's a good concept. If you do not need to analyze data, and just say, hey, we are super transactional, we just push data out and it's more booking system. Also, their concepts are out there, in the Lakehouse environment, mainly 𝗬𝗏𝗽, which is perfectly already supporting this use case. So I do not see many use cases where it does not fit. Technology is evolving very much in this area.
Okay, and maybe one last one, which is a kind of a follow-up question, which I'll just address to you as well, Thomas. How are well-known warehouse concepts like data historization and versioning realized with Lakehouse?
That's a good thing. That's the best thing. You do not even need to care about this, because it's really baked into the concept itself. For sure, if you make a snapshot of something, that is an explicit step that you have to do, and that needs to be done, or if you want to do a backup. But the historization itself is a quick win of adapting a lakehouse concept, because the cool thing is that it's automatically there. So you can add to each SQL query, you can simply add as of, and then you take a timestamp of the history and you have that data. So the structures, the operational fact data, all is from that point in time. And when you then think, you can even mix it and say, for instance, hey, please give me our current sales in the sales structure of last year. If you do this in a classical relational warehouse, you break all your fingers, because it's a lot of work to do. And that's an easy one in the Lakehouse concept. So I would say 95% of what is versioning and all of this stuff around is already contained in the concept itself. And finally, I want to point out to tools like Dremio, because they on top provide a Git-like experience for data. So that means you can check in data, do something, do ingestions, and find out, oh, anything is messed up, and you can easily switch back. And all these things are, when you are in a classical warehouse, you always, does this will work? Yeah, and all these steps are getting very easy and lightweight with the Lakehouse concept.
Okay, cool. Good segue to Will maybe. So there's a question here that says, my company already has Databricks. Why should I use Dremio?
Oh, you can use it if there's benefit. So without going back to presenting my certain parts of my slides, you notice that we have the different capabilities. So we have the engine, we have a catalog, things like this. And 𝗬𝗄𝗏 was probably a good example where they substituted in and used from Dremio what was beneficial for their stack. So it's not like a warehouse where storage and compute is coupled, or you need to use lots of features of Dremio to get the benefit. I mean, we'd like it if you used everything, use our catalog and stuff, that would be beneficial for us. But for you use what works for you. So 𝗬𝗏𝗏 is a great example that I showed. The query engine they used wasn't performant enough, so they can just optimize the one part of their pipeline that's maybe struggling, or their one pain point they have, but they don't have to revamp the whole system. They keep the ETL as it is, what they're comfortable with, keep the BI end as it is, keep the UI they like, and just leverage the parts that work for them.
Okay, maybe another question for you, Will. A lot of customers want to move from enterprise data warehouse to Lakehouse architecture, but they're still not finding it easy to write into iceberg tables. And it goes on, it's a longer one, let me summarize. It says, so Lakehouse table is still evolving, needs a lot of skill set, additional components like Spark, Kafka ingestion is not easy, needs a lot of scripting. Any thoughts on that?
So in terms of the first point about reading and writing iceberg, a lot of that's also with the catalog and the options you're using. So the standards are there, and there's options from vendors, but there are some differences in what you can execute and what you can do with the tooling you've picked. So I think the first thing was pick the right catalog. Now is an interesting time for it as well, because Unity catalog's coming out with new features, and then also Polaris, which is the Apache-based data catalog, is coming out with more features. So it's an interesting time to make your choices. But yeah, so depending on your catalog, you may have some read and write issues there. There's interoperability, like I mentioned, between the formats, but depending on your tooling, you may have read and write with iceberg perhaps, but only read for Delta. So it's worth checking the specifics on the tool you're using.
Okay, and that's one very specific one, referencing your slide 9, and it says, how does Power BI read the data from Dremio and with what kind of interface?
Okay, so we have a good direct connector from Dremio to Power BI. I don't have the technical details right now, but we have lovely documentation on it. You're welcome to go and look at that. The deck wasn't meant to go too into the weeds. But there's you're not dumping data out into, say, a landing zone and pulling it in or doing extracts that way. It's a smoother process.
Yeah. Maybe I can report on this, because at my last company we had exactly this. All the users had Power BI in place, and it then was a direct query against a tool like Dremio, and we also had Dremio in place. Yeah, and that worked really, really nicely, and we replaced a lot of Tableau stuff with it, where you have also these hypercubes in Tableau, and we had performance increases of sometimes over factor 100. Yeah, so just by switching from generic either Tableau or Power BI querying down to this Dremio stuff. So it was really impressive, yeah, to see that. It's fast.
Okay.
That's it.
Yeah, and we have a lot of actually very Dremio specific questions, which I would think would be better served to be answered after. But maybe there's one more general one here, which says, are planning scenarios possible directly right back to Lakehouse? Planning scenarios.
Yeah, I'm not too sure what the question is asking there. You can write back to read and write, yes, but maybe I'll take that one offline with the others to understand a bit more what's being asked.
So in general, it is possible because it's so Iceberg is write enabled. Yeah, so you can do a transaction, yeah, on it and write back. And for sure, you have use cases where you do heavily write back, and that can be also triggered from front end. Yeah, but it behaves like a database. So there is no big difference between Lakehouse itself or relational database. It's as already said by Will, it's asset compliant, so you can post into this your new values and it returns as it should. Yeah, so it's consistent. Yeah.
Mm-hmm. And maybe one more general question. It says practically ETL also does useful stuff occasionally and prepares the data for self-service users. Is that part practically self-serviceable in the Lakehouse architecture, or who cleanses data, matches IDs, calculates KPIs, etc.?
Yeah, so the idea is that it moves more to an ELT kind of process. So you extract and load, and then the transformation's all done in Dremio. So you're not pre-configuring stuff and pre-transforming before it gets to Dremio. It all happens in one place. And that's why the self-service is quite powerful, because your business users get in there. And in terms of Dremio, it's SQL. It's not a specific flavor. It's not a new kind of programming language. And they manage that. In terms of the quality and how well of a job you do, that's more of a business process. But on a technical level, you can do what you want to do in the tool.
Yeah.
All right, great. Again, there's so many more questions which we'll answer after. Do you guys have any final thoughts before we wrap this up?
Yeah, I just can only say one thing: try it, yeah, because it's much lighter than you might expect. I really had a lot of fear when I stepped into this or out of classical data warehousing into this Lakehouse stuff, and it turned out there was no looking back in regards, oh, that was better. Anything was more lightweight, more performant, easier to manage, less problems. Also, an Azure data lake or an S3 layer below is so stable. You never have breaking it. Yeah. So, and that's all nice. Yeah. So it makes life easier. That's it. Thank you.
Yeah, and I'd echo that as well. So on a technical level, there are differences between, say, a warehouse and stuff, but as a user and how you're interacting with stuff with the UI, it's very similar. Like you're not learning a brand new paradigm. And that's how self-service works really well, because you do what you usually do, but it works better and it's cheaper.
Yeah.
Good, great. So
Okay.
thank you so much to the both of you. Thanks so much to all the participants for taking part.
Download the paper. So much in. Yeah.
Download the paper. You will learn much more about the data lakehouse there. Feel free to connect with Will and Thomas on LinkedIn, and maybe see you again. And thanks so much. Have a nice day. Thanks. Bye.
Bye-bye.
Like,